Okay, so what does the base 10 format look like for small numbers? Numbers between 0 and 1, or numbers that are in between the whole numbers? Well, let's see if we remember everything that we just talked about regarding numbers that are in between two separate numbers. Remember, we can divide every set of units into 10 smaller units. All right, let's see how good you are. Can you guess what each of these purple markers represent in terms of a decimal number? How about the first one, between 0 and 1? What would you guess that number to be? If you guessed 0.5, you are correct. Go ahead and try to guess the second number, in between 3 and 4. Remember, we can split the numbers in between 3 and 4 into 10 smaller units. So what unit do you think this could be? If you said 3.2, you were correct. Okay, try the third one. What would that number be between 5 and 6, with that indicator being closer to 6? If you guessed around 5.8, then you would be correct again. All right, let's try that last one. Notice it's in between 9 and 10, but not quite halfway. What number would be the best number to represent the position of that marker? If you said 9.3, you would be correct again. Okay, so remember, in terms of base 10, we had assigned the numbers before the first base 10 as being, in a sense, the first base 10 region. Remember, base 10 to the power of 1 is actually the number 10. But let's now look at the smaller numbers. As stated before, the numbers between 0 and 1. Notice that the numbers between 0 and 1 are outside of the base 10 to the power of 1 region. Before we go on and explore the numbers in between 0 and 1, do you remember what the number 1 was represented by in terms of base 10? Remember, that was base 10 to the power of 0. What would be the region in front? Well, to help us out, we're going to utilize the concept of zeros. Notice that there's 1 0 in front of the decimal point in 0.5. We're going to use that to help us understand how to write decimal numbers in terms of base 10. Now notice the 0 is now in the front versus being behind the 5. Because there's still 1 0 and it's in the front, we can use this idea to help us to create base 10 to the negative 1. Think of the negative 1 as being an indicator that the zeros will be written in front of the non-zero digit, instead of behind like in the number 10 or 20 or 50. Now, if we were multiplying when we were in base 10 to the power of 1 and base 10 to the power of 2, remember we were saying 1 times 10, and I said you will see later why it was important to have 1. Well, if we were multiplying in that region, and now we're going in the opposite direction, well, we will be doing the opposite operation as well. So instead of multiplying by 10, we will be dividing by 10. So 10 to the power of negative 1 literally means 1 divided by 10. And the answer that we get is 0.1. And if you look closely, it actually looks like the number 10 written backwards. And there's a name that we call that, and it's a tenth with a TH. We'll look at that deeper in a moment. All right, let's zoom in now between 0.1 and the number 1. Notice where 0.5 is. Notice now the concept of dividing the numbers in between two other numbers into 10 more units. You still see the same counting sequence. Look, you see 0.1, 0.2, but look at the last digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. And because of that concept, we can make the decimal system really easy to handle. Instead of writing another 0 to the right of the number 1, we will now be writing the 0 to the left of the number 1. And that's basically what that negative power indicates. But remember, we're just using the regions to help us understand the concept. The base 10 to the power of negative 1 is actually this number here, 0.1. Let's test your ability to identify where numbers should go on the number line. Where do you think these three numbers would go on the number line below? We have 0.35, 0.85, and 0.05. Use your understanding of dividing numbers into 10 more units to help you. Okay, so where would 0.35 go? If you guessed between 0.3 and 0.4, you are correct. What about 0.85? Where would that go on this number line? If you guessed between 0.85 and 0.9, you were correct again. All right, let's try the last number there. But before you make a guess, take a close observation. Notice that this one has 2 zeros in front of the 5. Remember, we're going to use this idea that we've created about being in a base 10 region to help us. Notice that most of our numbers in the base 10 to the power of negative 1 region all begin with 1, 0, and hence we have the power base 10 to the power of negative 1. Now look at the last number in our choice selection. Once again, it has 2 zeros. So where do you think this one would go on this number line? Well, if you guessed in between 0 and 0.1, you are correct. But what would we call this in terms of base 10? Remember, the previous numbers in the front all have 1, 0, and we said base 10 to the power of negative 1. In terms of regions, what do you think this region would be in terms of base 10? Well, because it's 2 zeros and in the front of the 5, then this will be base 10 to the power of negative 2. Now, what does base 10 to the power of negative 2 mean? Just like we said before, instead of multiplying, now we're dividing. So we're dividing by 2 sets of 10s. So 10 to the power of negative 2 is equal to 1 divided by 10 divided by 10. And now notice that there are 2 zeros in front of the 1, and if you were to look at it backwards, it looks like 100 written backwards. And the name that we have for that is a hundredth. Now let's zoom in a little bit more in between our 0 and 0.1 there. Notice now that 0.05 is in the middle. Recall that base 10 to the power of negative 2 literally means 1 divided by 10 divided by 10. Now, although we're talking about regions, remember that base 10 to the power of negative 2 is actually a number, which is 0.01. We only speak of the regions to help us understand how the numbers are interacting with each other. Let's try this again. Where do you think that these three numbers would go on the number line? We have 0.025, 0.075, and 0.005. Let's start with the first one. Where do you think 0.025 would go? Well, if you guessed in between 0.02 and 0.03, you are correct. What about 0.075? If you guessed that 0.075 is in between 0.07 and 0.08, you are correct. If you're a bit unsure of that, remember you could put a 0 after the 7 and after the 8, and it will look similar to 70 at the last 2 digits, 75, the number that we just guessed, if we looked at the last 2 digits, and 80 for the other number that it's in between. And that can help you a bit in making your selections. How about the last number, 0.005? Notice the difference between this number and the previous two. For this number, you see 3 zeros in the front. Remember, most of our numbers below start with 2 zeros. So if this one has 3 zeros, would it be in the same region? If not, then where would this number go? If you guessed in between 0 and 0.01, you would be correct. Now, because we have 3 zeros in front of the 5, in terms of our ideal region, what would be this region in terms of base 10? Well, if you guessed base 10 to the power of negative 3, you are correct. Now remember, base 10 to the power of negative 3 literally means 1 divided by 10 divided by 10 divided by 10. Now, if we were to summarize all of this into one chart, we will have a chart similar to the one that we did in the previous video. Go ahead and fill out the last question, number 5, on your lecture work packet. You notice that the first column has been done for you, entitled Base 10. In the second column, the first number and the last number have been done for you. Go ahead and fill in the rest. And then for the last column, entitled Name, the first and part of the last have been done for you. Go ahead and finish this table, and then tune in to the next video lecture.